Hey everyone, this is David here, founder of Stately, creator of XState, and we are doing a live stream with Farzad. Don't know if you want to introduce yourself, Farzad.
Hey, it's Farzad here. I'm a web engineer at Stately, and we're doing some cool stuff tonight.
Yeah, tonight or today, depending on where you are in the world. I'm
Yeah.
personally in Miami, just going to be attending React Miami and hearing some really awesome talks and just hanging out with the community. But what we're going to be doing today is actually really interesting. I guess we were self-challenged to make a Canvas app. And so this is just a basic, simple Canvas app where you could add shapes to the canvas, remove them, etc. So basically, Farzan and I are going to plan it out and start implementing it. And so this is going to be a multi-part thing, and we are going to just do it in, of course, a series of multiple streams. So let's start talking about it. Do you have anything to add to that before I go on?
No, just wanted to say that this is going to be a really long series, given that there's a ton of features we can build.
Yeah. So to give you an idea, we want to build something like, I mean, not exactly like, but there's like teal draw, right? And teal draw is very cool because you could move things around. You could add text here. You could add shapes with keyboard shortcuts. And behind the scenes, they are using a lot of state machine-like things. Personally, we use TL Draw in a lot of just things that we share with the team. I should probably move this back. Oh yeah, undo and redo. But with the Canvas app, there are so many things to think about. Not just the things that you might see on screen, such as the different colors and shapes, but even more advanced interactions like the ability to select multiple things, or if I press Shift and click something else, or moving things as a group, undo, redo, nesting, all this sort of stuff. And so interestingly enough, in our Canvas app, we're not using any sort of library for this, except for React, which I don't know if you could consider a library. I guess it is a library for UI rendering. In fact, I would explain that what we're doing is a Canvas app, not via React, but despite React, because we find we fight with it quite a bit. But yeah, so you have the same sort of notion where you could double click, add stuff, undo, redo, move things around. And behind the scenes, we are, of course, using state machines as well. So there's just a lot of interactions to think of in a Canvas app. And so the big question becomes, how do you actually model this using, state machines and state charts? So that's what we're going to get started with. Okay.
Yeah, so are we going to build this in the studio, or do we move to code?
Let's start in the studio. I like to just first put all of my ideas in the Stately Studio or Stately Studio. And so, I'm just going to, let's just call this a, diagramming app. I don't know exactly what to call this. And we have different states and events. But what I like to do before modeling, like all of the different states that it could be in, is to model the different things that can happen, just because those are typically easier to think about. So I was thinking for just this first, this first part in the series, we do something very simple. We have the ability to add a shape. We have the ability to delete a shape. And if we're feeling adventurous, we could drag and drop and move a shape. How's that sound?
Sounds complex enough.
Okay, cool. So I'm going to right click here, and I don't know if you could see this. There's an add self transition over here. So, okay, awesome. So let's just do shape.add. And this is for just adding a shape. And you know what? Let's be a little bit more specific because we're going to add boxes. So box.add, and we're also going to add a, box.delete. And we also have box.move, which, if we get adventurous enough, then, we'll go ahead and do that. But otherwise, this is, we'll clean up the lines eventually, but this is as simple as your state machine really needs to be, at least to start off. And if you're new to XState, this is going to be a pretty pretty reasonable introduction to just what you could do using that library. So we have box.add, box.delete, and box.move. Okay, so anything to think about?
No, maybe we want to get the boilerplate in React done first, and then move on to what we want to build. So I'm
Sure.
thinking we're planning out the events, right? So box that add, delete, and move are respectively the events that could happen, like basic events. Yeah, let's get some rendering done, and then we can get back to the state machine.
Okay, sounds good. So I have done zero preparation for this, and that's on purpose. Well, it's both accidental and on purpose, but it just goes to show you that we're going to be starting from scratch, blank canvas, no pun intended. Actually, that was completely intended, but we're using the XState React template in TypeScript in order to do this. And so we have an app over here. We're just going to delete all of this, and actually, yeah, just pretty much all of this. Canvas goes here. Let me see if I could, oops. Aha, I found a state machine issue here. If any of the Code Sandbox team is looking at this, then there you go. That's a tiny little issue. In fact, I'm just going to get rid of this for now, just so that we could see what we're working with. A few technical details. There's many ways to create a Canvas app, and so I'm just going to go back to this and back to TL Draw 2. With like there's stuff like Go.js, there's JS Plum, there's so many of these different things. In fact, what's funny is right on the homepage of Go.js, you see this Statecharts thing here too, where you could zoom in. I hesitate to call this Statecharts because I don't think you could actually add states inside of here, but it is pretty cool that you could do this.
Yeah, it's a state machine.
Yeah, it's state machine. So, again, the difference between state machines and state charts is that with state charts, you could have nested states. But in Go.js, if you can see this, it's using a canvas. And so there's a lot of pluses and minuses to using things like a canvas. So the big plus is performance. So with a canvas, the only thing you need to think about are the pixels rendered in the canvas. And so Canvas tends to be pretty fast at that compared to manually building things and putting it on an HTML or even an SVG view. However, the downsides, which actually ended up being deal breakers for us, are it lacks things like accessibility out of the box, the ability to render React components inside. So each one of these is a React component. You could see we have interactivity where you could type stuff in here. Just put that back. And you could even do things like render markdown. So if I were to, I need blocks already, Farzad. So render a markdown description, and let's make this a heading. I don't know how big this is going to be, but the whole thing is bold.
Yeah, for people who didn't know, we support basic markdown in the description blocks.
Yeah. So you could see here we have nice bold. So this is a React component, and it makes React, like its component model makes this really, really easy to do and easy to customize. Whereas if we were to use a Canvas solution, we wouldn't exactly be able to do that. And so this is the same principle behind TL Draw. TL Draw also uses not a canvas, but it's using a mix of HTML and SVG. Now, early on, we actually did have a big SVG, and then we used foreign object to render HTML or React components inside of each foreign object. Safari did not like this very much. And so we took a few cues from TL Draw. And so what TL Draw does is a little bit different. So what they're actually doing is they're rendering, you could see that there's an SVG block inside of here, but that SVG is inside of a shape div. You see this RS shape. And so there's a bunch of these things basically absolutely positioned inside of the canvas. And so instead of SVG with HTML inside, it's HTML with SVG inside. And so that model actually proves to be really, really intuitive. Like it works across all browsers. And so if you tried our editor in Safari, it mostly more or less works in there. And so that's exactly the technique that we're using. And so I actually sort of want to duplicate that here just to show you what's going on. So
yeah, to give you a little bit more like on the challenges that we had previously. Before, actually, David was the person who refactored this to support Safari. There were a lot of unpredictability around embedding HTML inside SVG. I don't want to. I mean, foreign object is the only way to do that, right? There is no other way to embed HTML in SVG. But the DOM model and the styling in CSS doesn't work the way you expect it to when you're embedding HTML in SVG. So by moving, like by reversing this approach and embedding SVG inside HTML, we're actually getting a lot more predictability around rendering, and most things work out of the box, which is great for us, because at a product level like a Stately Studio, you have enough complexity around your own problems and features that you don't want to deal with cross-browser and platform-specific issues.
Exactly. Okay, so I have Canvas here. I just have to make sure it's actually rendered on the screen. Div class name is Canvas, and we have a Canvas over here. But where is it? Wow, if I can't even get this basic HTML, then
that's okay. We're doing live streaming. These things are expected. I think there's sort of hot reloading issue with Code Sandbox. Yeah.
Yeah, there we go. Gosh. Okay. Cool. And then this app is being rendered inside of a root element. So I'm just going to say HTML body root. I never know what the where it actually lives, but I think I could do display grid place items center, and that's gonna, oh cool,
that's
there we
the
go.
Easiest way to center stuff these days.
Yeah, exactly. Good evening, Persip-tung. By the way, if you have any questions in the chat, you want to talk to us, this is very informal. Again, we are building a Canvas app using HTML, CSS, JavaScript with React, and of course, XState and the Stately Studio. And we're sort of going to, I mean, we're not going to recreate the entire Canvas here or the entire Canvas diagramming app in TLDraw, but we are going to show you the basics just to talk about how to model different events and things like that. So,
and we're gonna start off with a single state machine for managing most of the like the core behavior around the canvas itself, but we marketed this live stream, this series, as something that would focus on multi-actor communication and cross-app state orchestration, because we figured that this is something, because we get like tons of questions about that on Discord in the community every day, and we figured that this is something that needs a little bit more education, and this is something people are struggling with in the community. So fear not, we are starting off with one state machine, but we're gonna soon extend it to more features, and more features mean we're gonna distribute into more actors, more global actors. There's like a receptionist pattern, and then we'll get to multi-actor communication in a few streams from now.
Yeah. So we talked about like just adding different events, and these represent just different actions that can happen inside of our diagramming app. Right now, it's intentionally simple. We could add, delete, or move a box, but we actually need to keep track of each of those shapes. So I'm going to use Farzad's fancy context menu over here, and we're going to start off real simple. We're going to have an array of shapes, and it actually detects that it's an array, which is pretty cool, and it adds that to context. So we have an array of shapes, and we can't exactly dictate the shape of like what that array is going to be. We're going to be doing that in TypeScript. But let's see what else. We have the shapes, and actually, let's just start there. Sound good?
Yeah.
Cool. So I'm going to just copy this over from TypeScript over here. And so don't need all of that. So I'm just going to say const canvas machine equals create machine. And cool, I have all my stuff. I have my ID, which is diagramming app over here. I even have my schema. And yeah, Farzad did a lot of this hard work. So yeah, we have all of our stuff. So it's type safe right now. By the way, XState version 5 is coming out. And so you won't need to add predictable action arguments, preserve action order. You won't need to add any of that stuff anymore. but we have the basics of what we want to do. And it did type out our shapes as shapes of any. But let's actually make an interface for that. So I'm going to say, oh, yeah, let me do something else too. I'm going to...
Yeah, while you're doing that, the thing about context of schema is we're working on a lot of new groundbreaking features. As Laura says, we've been hush-hushing about it so far. It's going to be magnitudes better studio in a few weeks. We're going to make some subsequent releases in a few weeks that will dramatically change how you work with the studio in general, boost the productivity of the web users. I want to say that for now, you can't really go into the details of the TypeScript interface for context and event schema, but soon you'll be able to have multiple simple ways of defining the schema of the machine for both context, events, and hopefully more stuff like actions.
Mm-hmm.
And around that schema, we're going to build a lot of validation and linting. So yeah, more to come.
Yeah. Yep. And so eventually you're going to be able to do more and more in the canvas. Okay, so I made a simple shape, and I could have put these directly on the object. I just want to model this closer to how we do it in the studio, where we have a position, which is the top left position of the rectangle. And we also have size, the type, which is box. And I guess in the future, it could be just things like oval, or I don't know, something like that. And the color, which actually this could be any string. So I'm just going to put string here. And so in our context, I'm just going to make shapes, an array of shape. And just to get the rendering working, we're going to prove that this works. So again, position, the X is going to be 10, Y is going to be 20, just doing something random. Size, let's make the width 50, height 50. I have no idea how this is going to look. Color, Farzad, pick a color.
Blue.
Blue. Okay, gonna make it blue. And we're missing, oh yeah, so type. This is gonna be a box and one more thing. Just kidding, 0 more things. Okay, so now let's actually go into, basically we're using XState and the XState React package as a basic state manager. So we're gonna be using useMachine, and we're gonna be pulling in this canvas machine, most of which was actually just generated by Stately. And again, like Farzad said, we're going to be generating more and more things. So let's pull that in. Const state send equals useMachine. If you're used to use reducer, you're going to notice this looks really familiar. So const state dispatch equals use reducer initial value. You probably typed that a few times. Basically the same concept here, except the initial value is already part of the machine. So we could just use that machine directly. So canvas machine. And yeah, so we have our canvas over here. And I am going to just iterate through this, the shapes. So state, I'm going to get confused between state and shapes. But we have state.context.shapes, thanks TypeScript, .map. And we're going to have a shape. And since we don't have an ID, which we should, I'm just going to use the index for now. And let's actually make a shape component. So function shape. This is going to be, let's see, props, shape. Lots of shapes going on. And so all we're going to do is we're going to return a div, and oops, this div is going to be position absolute. Top is going to be shape dot on TypeScript.
I see a problem on, right, yeah.
Oh, obviously. Okay, so, whoa,
yeah.
Don't know what happened there. Props.shape.position.y. I really wish Code Sandbox had Copilot, because it would just do absolutely all of this for me. And that's actually another cool point. Have you been using XState with Copilot, Farzad?
Oh, yeah. It gets so scary that I turn it off, really.
It's, yeah, there's sort of like there's an unfair advantage of how much XState that Copilot knows. So if you're using Copilot, try using it with XState, because it works really, really well.
Yeah, honestly, just have a code comment or like, or even try it in a markdown file, try to come up with a description of the state chart, and it will generate the entire, like, the code, like the XState config for it.
Yeah.
It's pretty cool. While we're developing, Kyle had a question: is the alpha ready to be used for non-production type projects? I would say yes, because the alpha has been out for a long time, relatively, and beta is just next door.
Yeah, yeah. So I would actually recommend use the beta, because the beta is our finalized alpha. So of course there's going to be things that change, but we don't anticipate those to be breaking changes for 99% of use cases. I mean, that's what being in the beta period is all about, finding the bugs and just figuring them out. So log the shape here.
And the entire migration from V4 to V5 should be pretty smooth sailing. So if you encounter anything, just let us know, please.
Yeah. I'm going to hide this file thing over here if I could. There we go. And we are going to inspect here because we should have a shape, and we do. It's just at our position top left.
There's no width and height.
Yeah, so width, props.shape.size.width. And then, so now you should see we have our blue little rectangle. So again, this is where we're not really changing state. We sort of hard-coded this shape into there, but we see that we are actually, rendering a shape inside of there, which is pretty cool, or at least sort of cool. So let's
So are you planning, David, to build interactions around this single hard-coded shape and then try to tackle the rendering, like for the entire shape space on a data structure?
No, we're going to actually add shapes for real. So
I actually knew that. I wanted to I had to build a hype around.
Yeah, that's awesome. Okay, so here's what you may be thinking. Traditionally, when we're doing just state management and stuff like that, let's say that I add an on-click handler onto here. And so inside of this on-click handler, this is where we might do things like, okay, create the shape and then do whatever. The whole idea behind XState and state machines and these events-driven libraries in general is that your UI should be as minimal as possible. So the only thing you should be doing is sending events. And so let's actually do that. So we could just send, and this is going to be type. Let's do box.add. And we do need a few more things. Schema is coming soon to Stately Studio, but for now, we'll just add it in manually. It's simple enough to do it. So I'm just going to give it a shape. And so this is going to allow us to add a shape. And so let's see. And now it rightfully yells at us saying like, hey, you're missing a few properties over here, or one, actually. Actually, it doesn't say that.
Yeah, I'm loving the TypeScript integration.
Okay, so we're going to create a shape. The position is going to be, we're going to get basically where we clicked on the mouse. So this is going to be X, event.client X, and Y, event.client Y. I don't know if you could tell how many times I've done this way too many times. Width 50, height 50, color orange.
I mean,
just
to
distinguish, and the type is going to be a box. I mean, we're only doing one type for now. So the idea is wherever you click, that's where a shape is going to be added. Obviously, it's not going to work right now, but just want to talk real quick about like the, I guess, creating a transition. So by the way, these are transitions on the root. So let's add some.
Yeah, so if you define a transition or the on property, which reacts to the incoming events to the state machine on the root level of the state machine, that means they're going to be available regardless of what the state you're in right now. So they're basically they're like global events to the state machine, if that makes sense.
Mm-hmm.
So this means if you later on refactor your machine or change the structure in a way that you're changing the hierarchy of the states, you still will receive them regardless of the current state, which is pretty cool.
Yeah. Yeah, and so that's where using a state chart, really makes that flexible. You could just move those, like Farzad said.
one of the aha moments of using a state chart for me personally was, David, where I realized that everything is just a state node and everything is recursive. So the API just completely gets more predictable if you realize that the entire thing is just a recursive object.
Yeah, exactly. In the new documentation, we are going to have better guides on that just to make it more intuitive. But yeah, that's the basic idea. So let's go ahead and we're going to do, if you've worked with the Zustand or Redux or use Reducer or Pinia with Vue or whatever they use in Angular, this is going to feel really, really familiar to you because we're immutably updating the shapes. There's a nice little assign syntax for that. This builds an action object that XState uses to update the context of this state machine. So we have the event, and the event is going to, have all of our, our shape properties in there. And so we're going to say return context.shapes.push, and we are just going to grab that event.shape. Now there are some type errors just because it thinks context is unknown for some unknown reason.
Because it's because it's an inline action. So if you refactor it to be a named action, problem is gone.
That's true. I was hoping rearranging this would help, but it doesn't. And also, we're fixing a lot of these type issues in the upcoming V5 beta. So if I click, okay, cool. So let's see. Oh, this is why mutation is dangerous, Okay, you see, it's almost working. Almost, because I'm clicking, but it's actually showing up in the wrong area.
There's a random factor to this feature.
Yeah. No, but it's actually fine because we are going to get, canvas position. We're going to use a relative position. And this is going to be the event dot target dot, so let's do x, event dot target dot client x. And I always forget whether it's event.target or events.currentTarget, but we're going to use target for now. And if that doesn't work, then we know that it's the other one. It's usually how a lot of my programming goes. Try one thing. If it doesn't work, then try the other thing. Okay, so here's the thing. When I click here, let's say I'm clicking on like 50-50, but this is already like 10-10. So we have to subtract where the canvas is from where we clicked, and that will give us a relative position. So x ev.clientx minus canvas position.x, same thing here, minus canvas position.y. So now when we do this, it also doesn't work. So I'm trying to think. Oh, sorry, this makes no sense. So const canvas rect equals event.target.get bounding client rect. TypeScript is not being very helpful here, even though it should be, but it's not. So now we're going to use the canvas rect instead. So this is canvas rect.x, and then we have canvas rect.y. So,
yeah, that looks okay. Yeah.
There we go. So now, very simple. Not a very useful Canvas app, but yeah.
So David, do you want to take this? Did you already have a talk with Dan Abramoff about making XState suspense transition compatible?
Yeah, so those conversations are still ongoing. We have a big Twitter thread about it. The main idea is that not XState, but React is sort of at odds with state management libraries that want to control the state. And the reason is because React wants to, I guess, control as much of the state as possible, which itself is sort of a failing proposition because it's impossible to control all the state. You are always going to have external state, but I understand the reasons for React wanting to do so. It's so that React could more closely control rendering. So being able to do things like pause subtrees when something is suspended or something like that. But the point of the matter is that XState and use machine, it assumes, first of all, it's framework agnostic, XState itself. And so when you're using XState with React, we're basically using the React hook called useSyncExternalStore to sync with, well, that external store. And that makes things pretty simple conceptually, because all you're doing is reading and sending events to this centralized store, just like you would do with Redux or Zustand or anything else. But the problem is that, React wants to use its own like built-in way of doing state. So using use reducer, use date, use effect, all of that, just because it can more closely control and work with things like concurrent rendering. So yeah, we've been experimenting back and forth. There's a lot of questions on when effects actually get executed that are still up in the air. Not too sure about that. So there's a lot of open questions there, and we're still experimenting, but I could share the results of my current experimentation right now. It's actually pretty cool. We basically made a mini XState using only React hooks. So use states, use reducer, use effect. And it's actually the same shape as an XState machine. So you could copy and paste that and visualize it, which is pretty cool, but it just lacks a lot of features that XState has.
So the main distinction between how XState is integrated into React specifically in comparison to other state management, like external store-based state management libraries, is that XState accounts for effects, right, David? If I understand correctly.
And XState accounts for two types of effects. We have the what are called invocations or invoked effects, where it's long-lived. It's from the state where it's defined, and it stops when you leave that state. And then there's the idea of fire and forget effects, which happen on the transition. And so in React, the equivalent would be the effects inside of event handlers versus the effects inside of use effect, which are closer to those invoke effects. So yeah. Okay, cool. So I have we have our boxes. Let's figure out what to do next, because
do you want to do selection next?
Yeah. We could totally do selection. So first of all, I'm going to get rid of my dummy blue box, because now we know that that works. Okay, so again, for those of you who missed it, we could just click around here, create boxes, no big deal, pretty simple. Now, where it gets really interesting is selection. So we have the position of all of these boxes, and guess basically what we want to do is we want to be able to select, oops, I'm just clicking around here. We want to select multiple boxes. By the way, I realized that we want to use target instead of current target current target instead of target, I think, because if I click here, notice how it goes all the way up there, and it does it relative to this box, which is not exactly what we want. So let me just fix that real quick. Again, I have no idea if this will work. We'll see. There we go. It works. So if you learn one thing from this whole thing, it's the difference between target and current target. So current target refers, I believe it refers to what you're actually attaching the event listener to versus what's being clicked.
Exactly. Current target is the one that owns the event handler.
Yeah.
They could have just named it better.
Yeah. Okay, so now let's get to selection logic. So I'm going to give each of these an ID, and we're just going to make it a number because, Farzad, you're going to see how lazy I'm going to be. And my laziness knows no bounds. My ID is going to be, actually, yeah, not that random.
Here's my boss, ladies and gentlemen.
Okay, so the ID is just going to be a random number or whatever, but this is going to be important for the actual selection logic. And so we need to add something to context, and it's going to be our selection. And so selection is going to be just an array of numbers.
Are you trying to use that number as a unique identifier for shapes?
Yeah, should be fine, right?
Okay. Yeah, I was just wondering.
You're scaring me, so I'm gonna use a string. Okay. And you know what? We'll use another date.now. No collisions,
Oh my
right?
god. Okay.
Okay, see, everything still works, you know, everything's going fine. But we actually want to be able to select some things. Okay, so here's what I'm thinking, and this is why I actually really like modeling using events first. And so if we go back to our state machine, we have box.add, box.delete, box.move, and now, oops, add this here. So type, we're going to add box.select, and this is going to add it to the selection. So box.select, and then that's going to do something. So
Yeah,
we
it's
have
great that we're doing selection first, because deleting its shape and moving it is it needs the selection to be happening before. So
right.
it's like a prerequisite.
Now this is going to take our ID. So this ID is a string, and so we're saying we are selecting that that ID.
That particular shape, yes.
Exactly. So actions assign, and we are going to be modifying the selection. And so I just need the event for now, just because for now we're going to just select one thing at a time. And we're going to get into the logic of how we could select multiple things later. So this is going to be just event dot ID. And again, like Farzad said, if we move these to external, or not external, but just like the referenced implementations, and then add them down here, then the types will actually be better. And in version 5, they're going to be better anyway. Okay, so one really cool thing about using a state machine and not trying to do things directly is that we could just basically inspect that state. So I'm going to just do console.log state.context.selection, just because I want to see that we're actually selecting things. And I'm going to say that that when we click here, this is going to just be this is going to be selected. So we are going to send type box.select, and the ID is going to be that shape.id. So onClick isn't implemented in shape, so we are going to add that. We're just going to say onClick, and doesn't matter because we're not really passing in anything. So onClick equals props.onClick. Okay, so let me pull up the console. We could click here.
So here's the thing. Since we are creating a new shape on click, we can't really model the selection because they're both conflicting in the click event.
Well, so we have a way to actually prevent that, and so we could do this here. Event, we're going to do events.stop propagation. So we're going to stop it from going up, and then we are going to call props.onClick. So you see, we clicked inside here, we have our selection. Now, if we change it, I'm going to use math.random because those numbers are very, very close to each other, and at home you probably all cannot see exactly.
Why not just a toString of the index? Maybe that's more predictable. Just do it your way.
They're different enough. I mean,
you're telling me this is more predictable?
No, not at all. Like this is you know what? Here, I'm going to ask chat. Write me this function that gives me a random, 5-character string.
Oh, it's going to use the toString with 5, I guess. There was a way to do that. There's a stupid way to do that.
Yeah. Okay, generate random string length. Oh, okay, so it went above and beyond, and okay.
Okay.
Come on, ChatGPT. Like, really? Do we need all of that? Okay, initialize an empty string, loop for the desired. Wow, this is like the most naive implementation possible. I'm sure that there's ways to code golf this, but I appreciate you, ChatGPT, for at least doing the effort. At least we know that this is going to work.
Here,
So,
the easy way, David, is to do method random to a string to the size you want. And pass a size like 4 or 5 or something. You can pass the radix.
really?
Yeah.
Doesn't
okay.
really.
Actually, we need to slice. I'm sorry about that. Never mind.
No. It's okay. It's okay. You tried.
See, this is why the AI can take over.
Okay, generate random string. We're going to do 5. Okay, let's go.
Okay, here's Taylor, my former colleague at Epic Games. Why not window.crypto the random UUID?
Window.crypto. Honestly, that sounds cool enough. I am vaguely familiar with that API. I've never actually used it, so let's try that. So window.crypto. Oh, it's on there. Cool. Random UUID. Hey, that's cool. I'm going to use it.
Works.
I like it. I like it a lot.
Maybe do you want to assign like a border or something around the selected shape?
Yes. Yeah. So let's go ahead and do that. So we actually, this is a really great opportunity to introduce something that's sort of new as of a month or a few weeks ago, called Create Actor Context. If that's available here, which it's not because I'm not using the latest XState React, but we could easily change that. Let me just go ahead and update a few more packages there. Okay, so if you're not new to XState, or if you're new to XState with React and you just want a simpler way to share something with basically everything within the subtree without having to go through the context mess and everything, then there's a really, really cool API that you could use called Create Actor Context. I know that Farzad especially has been asking for this for a long time. So I'm going to say this is going to be called Canvas Context, and we use Create Actor Context, and you pass in the Canvas machine.
We've been using this pattern internally at the Stately for the past 2 years. We thought, why not just make it part of the API?
Mm-hmm. And so now you have canvas context.provider. You don't need to add anything else. That's unless it yells at me. Oh, because I don't have a closing tag, obviously. And so what's cool about this is that I'm going to do a little bit of housework over here. So function canvas, and I'm going to return this. And then we have to actually get send from the machine, but we're not going to be using this. Instead, let's get the canvas in here as well. We are going to be reading from the actual const. This is a cool part. So const state send equals canvas context dot use actor. And there you go. So now, hopefully, this should all work just the same. And so what's great about that is I could copy this, bring this over to shape. So now we have, everything here, and we could see if it's actually selected. So I know I've been talking a lot about, just in the past, about these Boolean variables, like is selected, and why they might be iffy. I think that these Booleans actually work great as derived state. So not sorts of truth state, but derived from your actual machine. So I'm going to use selector. Yeah. And so we're going to say return, state dot context dot selection dot includes, and we're going to see if it includes the shape.id. So seems pretty simple.
Props.shape.
Yeah, const shape equals props. And so now we could say is outline is selected. What do you want? Like 2 pixels solid red or something? Or otherwise undefined.
You had the opportunity to use any other border type than solid. They don't they don't get enough chance to be used. You had the chance to do that.
How's
Anyway,
dotted?
is outline a more accessible way than border? I'm just curious.
I just like it because outline does not contribute to the actual layouts.
Oh, right. Yeah, that's
So
true.
yeah, you could
That's
actually,
awesome.
I don't know if people could see that well, so I'm going to just make this 4 pixels, just to make it a little bit more bold. There we go. So now we could select shapes, which is pretty awesome.
Yeah, so far the heavy lifting wasn't really done inside the state machine just because there's not enough complexity yet. But
Yeah.
now that we're going to bake a lot of other interactions around the current features, you're going to see like the benefit of using the state machine.
Yep. So one more thing, and then we could talk a little bit about it, just because I think we've made pretty good progress so far. What I want to do is just add deletion. So, and we're going to do that just by pressing the delete key. I mean, it's going to be pretty simple. And so delete, here's the thing with Canvas apps. Like, you always have a selection, whether it's empty or not. And so when you delete and when you send a delete event, you're not always saying delete this specific node. I mean, you can, like, there might be times where we might want to like right click. You actually can't see my context menu over here, but just imagine that we are right clicking, or there's like a little X over here. And so without selecting, we could delete. But what I want to happen is I want to delete whatever's in the selection. So, I'm actually feeling dashed for this. It just feels more bold. There we go.
Thank you for giving them more opportunity to be shown.
Anytime. Okay, so we have dashed here, and so we want to delete the selected one. So let us go back to our state machine. Box.delete, actions, sign. And so what we're going to do here is we're going to go through the selection, and we're going to basically remove all of the shapes that are in the selection. And that's pretty much it. So
maybe
shapes.
we better rename this to selection delete or something.
You're right. So okay, let's do that. That's a good call.
Yeah, I suggested that for our own sanity for next session.
Yeah, and so yeah, actually that's a really good point, because box.delete, it might have an ID, and so you might want to delete specific boxes or shapes. This should really be shape. And we also have selection.delete. So this is going to be selection.delete, and we are going to be affecting the shapes. So we're going to read from context, and we're going to say that the shapes should be context.shapes.filter, and we want only the shapes that are not part of the selection. So context.selection.includes shape.id. I think that'll work, right?
Yeah.
Oh,
we actually didn't wire it up to the keyboard.
Yeah, okay, so this brings me to one of my other like pro tips, or whatever you want to call it, for working with state machines. Wiring things up to the UI, it takes time. And of course, state machines make it simpler because all you have to do is send in events. But honestly, I'm a little bit lazy. So, I don't want to do that all the time. So what I'm going to do, I'm just going to be really lazy over here. And this is not approved React. This is just me trying things out in development. But what I'm going to do is, let's see, we have use actor. I have const actor ref. Actually, I'm going to go direct. We're going to say window.canvas actor equals canvas context dot use actor ref. And so this is the reference to the actual actor. I think you could see where this is going, maybe. Let's open up the console and see what happens. So I'm clicking around and cannot add, well, wow, geez, that's just CodePen doing its thing. But we have, what did I call it? Canvas actor. So let's see what that is. not defined. It's probably because I'm not in the right frame.
Maybe you want to open it in a new tab. That's just easier.
Oh, yeah, you're right. You're right. New window or new...
Yeah, that works.
Cool. Okay, I
Much better.
think that this is going to work. Let's see. So we have canvas actor, and we
Yes.
have it over there. So let me zoom into this a little bit. Fortunately, I don't know how to hide this, but whatever. Okay, so if we type canvas actor.get snapshot, we're going to see the entire state of what we have over here. So if I add some shapes and I select one, I want to see what the selection is. So let me look at the context. We have a selection of this ID. Let me copy the string contents. I wonder if that's correct. Cool, it is. So now we could work with the actor directly. So canvas actor send. Unfortunately, it doesn't type check, or it doesn't autocomplete over here, but that's okay. And we are going to... Oh, wait. I didn't even need that ID. Sorry. Well, all we have to do, this is much simpler. All we have to do is send selection.deletes.
Yeah, I was about to say that, but yeah. Great.
Yeah.
There you go. Disappear. Awesome.
There we go. Cool. So without even wiring things to the UI, you could test that your logic works, which this just makes it a lot quicker to work with. And I'm going to admit, while I was working on the the actual stately editor canvas, I was doing that a lot just because there's so many things going on in our UI that it just makes it a lot easier to just do things in the console.
Admittedly, I still do that when developing features on a Stately Studio. But there's also one upside to this approach, and that is imagine that your entire logic can now be tested in memory if you're in a test environment without having a UI.
Exactly, yeah. So this entire machine, you see here that it actually really has nothing to do with the window or with the, just the environment that you're in. So you could test this just in isolation and just make sure that the shape is correct, etc. But yeah, let's...
David, maybe you want to answer this before we get further.
Yeah,
Could you have dev tools for this?
No, not yet. But actually, what's interesting is that with the XState inspector, and so if you install XState inspect, let me do that real quick. I don't know about you. I'm having way too much fun on this stream. Yeah. So I'm going to install XState inspect, just speaking of dev tools, and we're going to import inspect from XState inspect, and then we're just going to call inspect iframe false. This API will probably be changing once we do beta. And then we have to do one more thing where we have to go all the way down here and provide some options. Tools, true. I believe that's correct. Let's just double check that real quick. Hopefully it opens it up using our...
I wonder why the TypeScript types aren't working. But I mean, we worked on that. I remember that.
All right, so I'm going to add 3 boxes here and then 1 box down here. I'm going to select this box, and eventually we're going to have like proper Chrome or browser dev tools for this. But you could go in the visualizer, and I'm just going to click selection.delete over here. Oops, there. So it's gone. If you missed that, let's do it again. In fact, I'm going to just have a bunch here and show you that there's this one or this one. I don't know. Sorry, I'm just choosing a random one. It's going to disappear. So selection.delete. Then you go here. If you want to do it side by side, which I can't do in this view exactly, actually, but
David, could you go to the inspector tab, and there's a tab that shows the state, the second tab. You can see that there's something in the selection, and then the moment you click on selection delete here, that's going to be cleared from the state, from the context.
Yeah, so you see the state over here. If I click selection.delete, boom, something's gone.
Selection is still there, but I think that's a syncing problem.
It's not a syncing problem. It's actually a bug that you discovered.
Okay.
Because, and this is another feature too, box.select, selection.delete, we're not doing anything with the selection.
Oh, you're right. Yeah.
So
It just happens that
just like
that
that.
shape isn't on canvas anymore to be shown.
Right. All right. So now when we create some shapes, boom, 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 select one of them, and we see we have a selection, we have a bunch of states. When we delete, it's going to both delete the shape and also delete the selection, which it did. I actually forgot which box it did, so just for my own sanity, I'm going to click this again. There you go.
Yeah.
So
another question, not more of an information than question. With keyboard shortcuts, I like invoking a callback function that lives on the parent state. That is exactly what we're about to do.
yeah, and so I think this will be the last thing that we do, just because we've gone through a lot over here. So we're going to do this two ways. We're both going to do it with my favorite React API, which is use effect, as you know. And then we're going to go in, we're going to refactor that inside of the state machine itself. So use effect, and I might need your help with this, Farzad, because I actually forget if it's key down, key press, key up, and then what the key code is for this.
So what do you want to do?
I want the delete key to actually send key down, you said?
Yeah.
Okay. And so if event.key equals...
I think event.code is what we're looking for. But
here's what I always do, because I always forget console.log event.key. So if I'm in here, oops, okay. This is why we actually need browser dev extension or whatever, because it does get a bit annoying. Oh, it's backspace. Weird. Okay, so we'll use backspace. Okay, so if the event.key is backspace, then we want to go ahead and send that over to... I
want to send the selection.delete event.
Yes. Okay. Get this out. Gonna press delete, and it's deleted. So
yeah,
that's pretty cool. I want to show you something. Sorry,
sorry, as to what Chris said, I just want to say that this is the easy way to do it, but we're going to eventually move it into the state machine, because we don't want this to be available in all of the possible modes on the canvas later.
Right. Before that, I just want to show something really, really fun. So key down. This is pretty cool. So I could add a guard. I mean, in version 4, it's called cond over here. But we're going to say if event.key is backspace. I think you could see where this is going. And we're going to do something really interesting and really, really, really powerful called raising an event. And this is something that you can't really do normally with Redux or anything like that, where you could tell the state machine to send itself an event. So I'm going to tell it to send myself selection.delete. And so there's a whole bunch of red just because just because I haven't defined this key down events, which don't worry about it. We're just coding for fun here. And so now instead of all of this, check it out.
Just send the event. Yeah.
Try it out. Still works.
Why not? Yeah.
Oh, and I forgot, you have to add the cleanup and everything. Otherwise, you're going to leak memory, etc.
You're going to send to selection.delete in the dev mode.
So let's say that you did not want to use effect because, it's just an interesting API. So invoke, let's say that, as a user, it's like, okay, we want to be listening for keyboard events, just the whole time. So I'm just going to call this ID key down. And the source, we're going to be using a callback actor. So this is going to take, it already takes like context and event, but we're not going to be using those. We're just going to be sending back some stuff. And then we're going to say const handler equals, we don't need a handler because all we have to do is
send back.
Yeah, document dot add event listener key down, and you send back that event, and then we could return, just to be good citizens, return documents dot remove event listener key down, and it's going to be that same send back function. This actually looks very, very, very close to what your use effect is going to do. And so remember, we removed that use effect, or at least I think we did. No, we didn't.
We did.
Not yet.
It didn't?
Oh. Cool. So click, click, click. And it still works. However, what's the problem over here? Or not really a problem, but what's the main issue that you see over here?
Are you asking me?
Yeah.
I don't know.
Well, it doesn't become very testable, right?
Sure.
I mean, because we're relying on the document and we have it inside the state machine, right? Yeah. So I'm just going to put here key down listener.
Right. We're going to use something called named options in XState, where you provide the implementation either on the call side when you're using the state machine inside your component or wherever you're using it, or as a second argument to create machine, or other APIs like the create actor context.
Yeah. So I'm going to put the key down listener just over here. I hope that still works. Yeah, cool. So it still works. And now we're going to go back from where we came from. I'm going to copy this over, and we're going to go back to the Canvas app. And I'm going to just import this. And we're also going
to have to do a layout.
I think how the layout is sort of upsetting me right now. But that's okay, because we could just move these things out and get this. Okay, so we see that our diagramming app actually grew a little bit. We have implementations over here for like, here's what assigning does. We're invoking a key down listener. We have key down, selection.delete, box.add, box.move, which, we could just say here, not implemented yet. And also, one cool feature that we didn't really talk about in the past office hours is you could add an annotation. So, we could just say to do handle selecting multiple things. And I'm just going to leave this here so that we could, talk about what we want to do next time. Oh, this is weird. That's something I had to fix, but that's okay. So this is called an annotation node, and you could have annotations that just, they're just like notes. You can put them anywhere. So, yeah, we have
How many ways do we have in the studio right now to make an annotation? There was the context menu, and I believe there was also another way.
I think just the context menu is what you could do. So you can add multi-line notes here. And so we are going to be just, adding a lot more to this, like the ability to change colors and to manage your notes. This actually doesn't get exported. So if you go over here, you're going to see that we don't actually export those notes, but yeah.
Yet. Yeah, I mean, yeah, for annotations, yes, yeah. I thought you were talking about the invocation, sorry.
Right. But yeah, so it's been about an hour. I think we have a pretty good proof of concept. So just again, so you see, we have the ability to create multiple state nodes, to select them, or not state nodes, but boxes. Sorry, thinking about the Stately Studio. Select them and press delete in order to delete them. And all of that is abstracted in a way where, for example, this selection.delete, it could occur on button press. It could occur when you click something. It could occur automatically. Like just using events instead of directly manipulating state is really, really powerful. So,
and the more you build features into this model, the more you realize that investing into a state machine, especially for a highly interactive application like a graphical canvas application, is a really reasonable investment.
Hmm.
Um, Martin says to do just delete the selection instead of wiping the whole array. Well, you could argue that that's going to be unavailable in the render phase, so you're going to have to guard against that. It's just easier to
Yeah.
remove that
And
property.
if you really wanted to, like, I really like using Immer, and we're actually using it inside of the editor and Stately Studio. So instead of just mapping over, because that is a fair point, you could have like hundreds, if not thousands, of different shapes, and you want an efficient way to delete them. I'm not sure how efficient Immer is with doing that. Maybe it's just a nice wrapper over doing things immutably. But yeah, you could do something like, we have selection.delete. Actually, I'm not going to do it here, but we'll probably talk about that next time, just because filtering is the easiest way to do that. You could, of course, use splice in order to do that as well.
I mean, we could also
Yeah.
pick a different data structure to make it more efficient. But in general, the principles are around managing the like interaction complexity and sending events to a state machine.
Hmm.
We can do like more nitty-gritty details in terms of data structures in the next stream.
Yeah. All right. Well, I think that's all for today. I had a lot of fun.
Yeah,
What about you, Farzad?
me too. Me too. Yeah, it's always a pleasure to watch you code because you're a really good live coder.
Thanks. Been doing this way too much.
So thank you for joining in today. This is again the very first episode of a hopefully long series of modeling exercises with me and David. We're going to continue with this graphical application for hopefully a long time. There's just a ton of features we can build, and yeah, I think we're going to have a lot of fun. We're going to try to stream a little more frequently, maybe a couple of times per week, just to keep the wheels rolling. What do you think, David?
Yeah, sounds like a plan.
Great. So thank you for joining in and see you next time.
All right. Thank you, everyone.
Bye-bye.